All right, thanks for joining Eureka McConnell Science Museum for a Science Sparks presentation. And today we have Fire Ecology in the 21st Century with Claudette Moore.
So thanks for having me. There's a lot to cover, so I've been rehearsing this, and I think I probably speak a little fast, but I'm trying to keep it within that half hour. So anyway, I was just going to start a little bit about my early career and how I relate to fire. When I first started working for the National Park Service way back in the late 70s, I got some experience working on fire crews and working on fires. Nothing like some of the stuff that we're seeing today. I had a much softer approach into fire landscapes. But after doing that for a couple of years, I got involved with, I spent several seasons working for prescribed fire crews in the sequoia groves in Sequoia National Park. So sequoia trees are one of the trees that require fire to release their seeds from their serotinous cones. So I did that for a couple of years. We would go out and plan fires in sequoia forests to clear the landscape, release the seeds, and remove some of the encroachment of the white firs. I did that for several years, and from there I took those skills and I transferred those to fire effects monitoring. So I got out of the actual burning, and then I got on the team that assessed the efficacy of the fire. So we had many fire plots that we would go in and record a series of data on the forests and evaluate them before the fire, after the fire, and then in subsequent years after the fire. And we would compare those to areas that had not been burned to see if we were getting the kind of seed generation and tree removal that the fires were designed to accomplish. So that's a little bit about how I have gotten involved with fire and why I've related to it all these years. Just a few, whoops, okay, enter. Uh-oh, why isn't this? Sorry, oh, there we go, sorry. Okay, so just a couple of notes and disclaimers before I get going. Fire is an extremely complex natural process, and I'm focusing this particular talk on conifer forests in Colorado in the Rocky Mountains. I did an extensive amount of research because I haven't done one of these talks in quite a while. And I mostly am staying away from numeric data because I'm trying to give just kind of a broad overview, though I do include some numbers, and I just want you to be aware that some of them are composite averages that I came up with based on the literature that I came across. And some of the other values are from the Forest Service and the Colorado Forestry Site, related more pertaining to these direct forests that I'm going to be talking about. So I just say that because if you do your research on your own and you come across slightly different numbers, that's why. I mean, there's always a range in figures when they give you years and dates for things. The other thing is, I don't regard fire as good or bad as an ecologist. It's a natural landscape process, and it results in change, and often significant change, which may be hard to adjust to, but it's part of the ecological process that happens out there in the real world. But of course, seeing and reading about you know, these wildfires burning through towns now, that's a whole other thing that I will address later in the presentation. But fire on the landscape is very natural and often has really good benefits. And so you have to kind of weigh that out. What we have to get used to is the changes in the landscape are, you know, something that are going to be with us for a long time. And especially for those of us who are older, we're not going to see a return to what these forests looked like before fires, certainly in our lifetime. So it's just realizing that they are very dynamic processes. So today's talk, I'm going to be talking about the history of fire management briefly, drivers of fire behavior in Rocky Mountain conifer forests, the factors influencing changing fire behavior, post-fire examples, and mitigation efforts. So that's a lot to cover in a half hour, so that's why I'm going to be speaking a little fast. The role of fire is an essential process, and it provides necessary nutrients and soil conditions for many plants to, whoa, we're on some kind of auto thing here, sorry. So many plants and animals in fire-dominant ecosystems are adapted to withstand fire. So they require fire to survive and be in those landscapes. And fire also maintains vegetation mosaics, so different patterns across the landscape, decreases vegetation density, and recycles dead materials. So a little bit about the history of fire management. Native Americans used low-intensity fires to manage vegetation and animal communities, and I think if you've lived in the West and you know, studied any of that, you've seen the legacy of that. Oh, again, I'm not sure why this is going forward like that. As European settlers came in, they sort of enacted a fire suppression because they were afraid of fire. They really didn't know how to manage it, and they didn't understand its role in the landscape. So fire started to be suppressed actively kind of in the mid-1800s, although there were some extremely large fires in the late 1800s and early 1900s because they really didn't have fire suppression techniques. In the early 1900s, fire suppression really got underway, and we've been living with the legacy of that for the last 100 years and trying to reverse some of that. Also, by the early 60s, some fire management folks began to realize the importance that fire plays on the landscape. And so they started a program to introduce management ignited prescribed burns on the landscape for resource value. As an example, this was early in the Sequoia Forest in Sequoia National Park because they realized that fire was very integral for regeneration. In the late 70s and early 80s, they also began to allow natural ignitions that occurred in the backcountry to burn under certain conditions. So if they had a lightning strike, they would go out and evaluate that area and decide, using natural boundaries, how big that fire could get out and just basically let it burn by itself. Okay, I'm not sure why this is on auto. So that's another tool in the toolbox that's been used. So managed fire, part of the reason that they use it is to restore natural fire intervals and diverse landscapes. And return fire intervals vary by ecosystem, which I'm going to talk a little bit about later. The use of natural ignitions and natural barriers under specific weather conditions. So you can't let these fires burn under just any conditions. There has to be very specific weather conditions that allow for safe management for these types of burns. So you're going to hear me talk a little bit about fire regimes, and what that really means is how fires burn. And there's several things that contribute to how fires burn. The first is intensity, how hot is the fire going to get? And the other one is severity, how does it burn across the landscape? Is it a ground fire? Is it using ladder fuels to become a crown fire? Is that fire spotting? So intensity and severity together sort of decide how big that fire could potentially get. So each landscape has its own fire regime. So the things that contribute to it: topography, how steep is the area. In very steep areas, fire can run up hills very, very quickly. Aspect, generally south and west aspects tend to be drier and warmer and theoretically less heavily vegetated. On the north and east side, you have cooler, wetter, often denser landscapes. So aspect can determine how a fire will burn through that vegetation. The vegetation type, which I'm going to talk a little bit more, also determines how a fire will burn. Fuel load, so what kind of material is on the ground that can carry that fire? Because most fires get started by being carried on the ground. So I'll talk a little bit about fuel loads, weather, and then overlaying all of that is climate, sort of these long-term weather patterns, how that affects fire going forward. So a little bit about the fire fuels. There's four fire class sizes. The first one is the 1 hour fuels. It's a small 0 to 1¼ inch diameter. And then you've got 10 hour fuels, so that's a 1/4 inch to 1 inch. So your 1 hour fuels are really what carries your fire initially. That's grasses, pine needles, leaf litter, small twigs, anything that can ignite quickly and carry your fire forward. The 10-hour fuels become more of an issue as the fire increases in intensity and can start to ignite those larger pieces. Then you have 100-hour fuels, which are 1 inch to 3 inches, and 1,000-hour fuels, which are 3 to 8 inches and larger. So you can see those if you've been up on the mesa on the ski trails where the snow melts. There's a lot of dead and down in these size classes. These would become more of an issue as a fire increases in intensity and can really ignite and catch this stuff on fire. But generally, most lower intensity fires are going to be built around your 1 hour and 10-hour fuels. So the conifer forest within the Rocky Mountains, which extend from Idaho and Montana down to New Mexico in the US, include 5 main forest types: the pinyon juniper, the ponderosa pine, Doug fir, lodgepole, and subalpine fir. I'm going to be talking mostly about the first 4. Subalpine fir forests do burn, but because they're so high, they tend to be cooler and drier and keep things kind of moving along. I am just going to talk about this first 4. So as I introduce these forests, I'm going to be talking about 3 terms related to these forest types. The first one I've mentioned is fire return interval, and that basically means how often can managers expect the fire to occur in this forest type. The next thing is stand replacing. So when you talk about a stand replacing fire, what you're talking about is a fire that's going to result in almost or complete 100% overstory or major tree mortality. And the last one I'm going to be talking about is mast crops. So all conifers produce seeds generally each year, but they also produce mast crops, which are years where they produce a huge abundance of cones and seeds. And that becomes really important in providing a seed source for being able to recolonize these areas. So the pinyon juniper forest occurs at an elevation between 49 and 800 feet. It has a fire return interval of 200 to 400 years and tends to be stand replacing. That's weather driven. And we certainly saw that this year with the Pine Gulch fire. We all got to live intimately with that for a month. Generally, you can have smaller fires, but if you look at the pinyon juniper forests, they tend to be more open landscapes. So there's not a lot of density. And in the really healthy landscapes, the ground cover is not continuous. So you've got these small clumps of grass and wildflowers. And so generally, if you get a lightning strike and it hits a juniper tree, it may burn that out and maybe even the next one to it. But generally, there's not enough fuel unless you have really dry conditions and mostly the winds. It's the winds that really drive these stand replacing fires because they can just throw flame lengths and sparks long distances. Again, as we saw with the Pine Gulch fire. Seeds in these areas or for these trees, the mast crops are every 2 to 5 years for juniper and 1 to 3 years, but only within a 10-year period for the pinyon juniper. And generally with our forests, what I've seen mostly is juniper. We don't have as much pinyon around here, but certainly as you go further south, you'll see more pinyon pine. So the next one is ponderosa pine, and it's between 6,000 and 9,000 feet. It's highly tolerant of low intensity ground fires, and generally when you see healthy forests, they have this park-like look where there's not a lot of ground fuels, you know, grasses, maybe some small twigs, some 10-hour fuels. They're highly tolerant to these low intensity fires because the bark is very thick and it also has that delicious vanilla smell that we all love. They can be susceptible to crown fires due to increased fire suppression, and what that's done is allowed the encroachment of, in particular, Doug fir. And that creates ladder fuels that will bring the fire up into the crowns of these ponderosa pine forests. The fire return interval for these low intensity fires tends to be about 5 to 25 years, and the stand replacing fires occur about every 300 years. Seed regeneration is relied from nearby surviving trees. So ponderosa seeds are fairly big and heavy, so they don't tend to be wind dispersed. So if you have a really large scale ponderosa pine forest fire, it's going to take a long time for it to recolonize naturally because it's going to be coming out from the perimeters and working its way in. Doug fir forests also occur at the same elevation, and young trees are pretty susceptible to fire because they have fairly thin bark. They become a little bit more resistant as they approach about 40 years. Fire return intervals for lower intensity fires are 35 to 75 years, with stand replacing fires occurring about every 165 years. They have wing seeds that are dispersed through winds, and their mass crops tend to be between 2 and 11 years. A couple of other things, the smaller intensity fires are actually really quite good in these forests because they help to diversify the landscape. They open up areas, allowing grasses and shrubs, which increases wildlife habitat and bird habitat. So, next is lodgepole pine, and it occurs between 6,000 and 11,000 feet, and it's susceptible to stand replacing fires because of the thin bark and dense forest stands. If you've driven up by the passes, you've seen these lodgepole forests. They're super dense with closed canopies, not much can grow, not much understory under there. They have fire return intervals, lower intensity, 40 to 175 years, but generally what occurs in there are these big stand replacing fires that occur 200 to 300 year intervals. The Yellowstone fire in 1988, which a lot of people considered quite devastating, occurred in these lodgepole forests. And as fire managers went in and evaluated after the fire, it had been about 250 years since those forests had burned. So from an ecological standpoint, they were right in their queue in terms of burning. It was a natural lightning strike. It did burn with a lot of intensity, and that was kind of hard for a lot of folks, but in the years since, it's been really interesting to read about and see the recovery in that area and how much land was then opened up to wildlife because these dense forests had been knocked back in that area. Lodgepole pines do really well because they produce a lot of seeds through serotinous cones, which are cones that require the heat from fire to open, and non-serotinous cones. So they can get reestablished pretty easily because of the abundant seed sources. Factors that affect changing fire regimes going forward: climate and weather and climate, drought, fire suppression, insect damage, and something called the wild-urban interface, which I'm going to talk a little bit more about. There was a really good article in the Washington Post this spring called "This Giant Climate Hotspot is Robbing the West of Its Water." And if you haven't read it, I would highly advise looking it up. This article really centered on our region of the country and talks about how we in Grand Junction are already experiencing 2 to 2.5 degree warming in the last 100 years. And the authors of this article spent a lot of time with ranchers and farmers who've been here generations and who have been watching changes on the landscape. Okay, I'm going to try to stop this just a bit here. So it's been a real big change for them, and they can see the changes over the generations that they've been farming. And one of the really interesting things about temperature records is a lot of these farmers, especially in the 1800s, early 1900s, you know, there was no formal way of collecting the way that NOAA does now and the Weather Service. These were just farmers reporting in their daily weather values. And those records have become incredibly important to understanding changes, especially at the local levels. So these recordings have really provided a lot of important information to help these local regions understand the changes that are coming on. So fire suppression is another thing that we're dealing with. And what fire suppression does is, as I mentioned earlier, create these ladder fuels. And then you've got the dead branches on the lower part of live trees. And all of this basically creates a ladder into the canopy. So fires can really get raging and lead to these, you know, sort of epic scale fires that we're seeing in the West right now. And we're still dealing with the legacy of 100 years of fire suppression and trying to get a handle on that. The other thing is insect damage. You pretty much cannot drive along a Colorado highway without seeing the insect damage. And just since 2000, spruce beetle outbreaks have killed almost 1.9 million acres in Colorado, which is about 41% of the spruce forests in the state. So, you know, the drought stress makes the trees more susceptible to insects. They don't have the resilience to kind of ward off the damage that insects are going to cause. And as you know, we've been suffering pretty extreme droughts. And this was just a drought map that I pulled off of the NOAA site in mid-August as I started preparing this fire talk. So, you know, once you get these dead forests, you get wind throw, you get broken trees, all of that leads to the potential for larger scale stand replacing fires as well. So the wildland urban interface, which is affectionately known as the WUI, if you haven't heard that term before, it's an area where human-made structures and infrastructure are in or adjacent to areas prone to wildfire. So that's the official definition by FEMA. So all these mountain towns that we have in Colorado and many mountain areas across the West have been growing in size. And between 1992 and 2015, 32 million new homes were built in the WUI. That's a huge number of homes. It has made the job of firefighters much more difficult because their primary thing is life and property. So as you build more houses, they're stretched thinner and thinner trying to save the properties. And that statistic was from the University of Colorado at Boulder. 75 to 95% of the fires in the WUI are human cause. It doesn't mean arson necessarily. There's a lot of inadvertent ways that you can create, you could start wildfire without even realizing it. So Colorado has a map, and I'm hopefully going to be able to show that to you briefly. So I'm going to get out of this, and we're going to go here. So if you get on the, this is in the Colorado Wildland, Colorado State Forestry site, and they have this urban interface map from 2018, and you can scroll over it, and you can see.
We're not seeing that yet. We're still seeing your PowerPoint.
Oh, you are. Huh. Even though I minimized it. Okay. Well, I will just say, if you go onto the California Forestry site, and you type in wild urban land interface, you're going to get this map that's interactive where you can scroll through and see where the heaviest concentration of WUI sites are in the state. So I apologize that you can't see that. I was hoping to show it to you live because it had some neat features to it. So we will get back to where we were. So this is a picture from Colorado. And you know, this is what it looks like when fire is bearing down on your community that is in a fire prone area. It's, you know, terrifying. I have several friends now who are in California who are on a pre-evacuation order from some of the large fires, and having been there, it's a very stressful position to have to be in. So land managers are working really diligently to try to improve the circumstances there, but it's challenging. Because we've had so many fires at this time of year, there's been a lot of news in the media about fires, and PBS had some reporting on it last week. So I was able to pull this graphic off their website, and this is the 20 causes of the causes of the top 20 most destructive fires. And as you can see, most of these are human related. You know, arson only accounts for 2. So when you say human cause, people sort of assume that everybody's just out there lighting fires. That's actually not really the case. Arson isn't, people do that, but it's not the main thing. There's a whole suite of ways that fire can start. And as an example, there's a fire that occurred in California in 2015 called the Valley Fire. and it occurred up around a reservoir town. And again, sort of being a fire geek, I was curious how such a destructive fire could get started. It killed 4 people and consumed 1,300 homes. And after the fire investigators went in, what they discovered was a gentleman owned a second home up there, and he had bought a used a used hot tub, and had done his own wiring improperly. And then he went home to his primary house, and there was some kind of short. So that hot tub fire was responsible for basically burning down his town. You know, there's a lot of just inadvertent ways that you can start fires. Another big one is chains from trailers. A lot of people like to leave their chain super loose when they're pulling a trailer so that the arc of a turn doesn't snap the chain, but you can leave them too loose. And as you're driving across the road, these chains drag and they spark. And when it's really windy, they can start fires. And that is a huge issue along the roadsides in summer hot conditions on windy days. So you can see there's sort of a variety of ways that humans can be involved with causing fires. Moving on to post-fire landscape recovery. We heard a lot about the Hayman fire this year because up until the Pine Creek fire, or the Pine Gulch fire, Hayman had been the largest fire in the state. And so there's a lot of work going into it. And I apologize, this isn't a very good photograph. It's a before or sort of after the fire in 10 years. I lifted it from a report, so the quality of the image isn't very good. But the top one was taken in August of 2002, and the fire burned in June. And the bottom one is 10 years later. From the top one, it looks like some of those pine trees survived the fire. But what happens is the intensity of the fire can be so hot that it really affects the cambium, and the trees do not survive. And you can see they've since died in the 10 years, and the area has been converted to mostly grassland and shrubland. This is a fire perimeter map, and the red indicates that there was very little to no overstory tree survivorship. So basically all of the mature trees, for the most part, died in the fire. You can see my pointer moving? In the area where it's white, there had been some other fires that had gone through and some treatments. And so there was a little bit more survivorship there, but for the most part, the fire had killed everything. And in this particular block, which is the Chesapeake Landscape Lake Reservoir, I'm going to talk a little bit more in a bit, which was of concern. These are some additional pictures that I found from reports that were done 10 years after the burn. You can see that left on its own, there's very, very little regeneration occurring. The landscape is really hot, really dry, and so it's been a tough recovery on its own. 2002 was also an incredible drought year. Just to give you an example of how dry it was, I pulled up some hydrographs from some rivers you're probably familiar with, from the Yampa at Deer Lodge. So if you're rafters, you might be familiar with, you know, summer rafting flows. And also from Colorado, the Colorado River at State Line. So the blue line is the hydrograph from this year. You can see that we had more snowpack than they did in 2002. That was the other thing that contributed to such the dry sources. There was just no moisture in the ground at all. Although our summer flows have been about the same, fire season got started a lot earlier because there was just very little moisture in the ground. Hayman fire started on, I believe, June 2nd. So it was way up here. So, you know, that's pretty early for a big forest fire to occur in Colorado at elevation. And because it was so dry, 6 of the largest fires in Colorado occurred in 2002. So 2002 was a big year for fire destruction across the West, but certainly in Colorado. The Chesapeake Reservoir was of particular concern because this is owned by the Denver Water Board, and it's one of the reservoirs that hold water for the city water supply of Denver. So it was pretty devastating to have the entire watershed consumed because it creates a lot of issues for the managers going forward. This is it 10 years later. again, not much growing back. So there have been many entities over the last, almost 20 years that have got involved in rehabbing these areas. The federal folks, the state folks, as well as the water board, and a lot of nonprofits have gotten together for rehabbing these areas. And one of the things that they try to do initially is go in and provide some slope stabilization, especially for the reservoir. You don't want all that sediment and silt in the reservoir. It fills it, which is not a good thing. But the other thing is there's a lot of toxicity associated with ash and chemicals and volatiles that burn that they did not want to have in the water supply if they could help it. So there was a big effort initially to stabilize as much as they could. And the other thing they've done is manually plant trees to help with the reforestation, because there was so much, so much of the overstory and the seed banks were burned that there's very little on the landscape. And so, this is a painstaking process to plant thousands and thousands of trees and hope they survive, because this landscape now is much hotter and drier than it was before the fire. Another fire that occurred in 2002 was the Big Fish Fire, and it burned only about 17,000 acres, but it was in the White River National Forest around Trapper Lake. And it resulted in the loss of some historic structures around the lake and around Trapper's Lodge. And why this area is really important is because this area is called the Cradle of the Wilderness. This is where Arthur Carhart, who was one of the founding fathers of the idea of preserving wilderness, kind of came up with the idea up around this area. And this is up by Trapper Lake. This is the Arthur Carhart Lodge. And as you can see across the lake, you can see the effects almost 20 years later of the fire that went through. A lot of the dead snags and just the buildup of that dead material on the ground through blowdown and snow and so forth. Here's another picture of the landscape you can see on the hillside here, where the trees have been knocked over through time, and some standing pole trees. And what's come back is a lot of grass and shrubland and wildflowers. And I just have to give a shout out to John Crane, who allowed me to use these photographs. He's a landscape photographer here in Colorado. Generally, I try to get my pictures from the public domain or from federal reports, but these pictures were pretty extraordinary. And so I sent him a message telling him about this talk, and he graciously allowed me to use these in the talk. And so I just wanted to give him a shout out. He has a wonderful blog that goes with this series. So if you're into beautiful scenery, I would check out his website. Along those same lines, another photographer that I ran into on the web was John Fielder, and he was another one that graciously allowed me to use his photography. And these pictures also show landscapes up around Trapper Lake following the fire. And again, you can see all the dead standing pole trees, but in areas that are close to the water, where the water table is higher, you see flowers and grasses coming in, and the opening of landscape to wildlife. So, it's a changed landscape, but a lot of the people up there now really enjoy the openness and a lot of the wildlife sightings that they get to see now, because so much of the landscape has been opened up over time. So one of the other things that I wanted to talk a little bit about is potential deviations from historic post-fire recovery. So since the early 2000s, when we've had some of these really large-scale fires that have occurred in these perpetual drought years, fire ecologists are kind of seeing some changes along the landscape. And one of them is that some of these forest types may be replaced by grasslands and shrublands over time. That's partly because the seed source has been consumed through these incredibly hot, intense fires. And then the other thing is the changing climate in these areas. It's hotter and drier in general, and that does not really sustain forests. So you're either going to have that or longer periods needed to reestablish forest communities through natural regeneration. A lot of these fires will have some rehab efforts done by local groups, by federal agencies, state agencies, but left on their own, these forests are going to take many, many generations to reestablish if they do at all. And one of the interesting things that I hadn't really thought about was, as these landscapes potentially convert to grasslands or shrublands, what's going to happen is you're going to have potentially less impact by these large, severe wildfires, because you're not going to have these expansive forest landscapes anymore. You're not going to have that intense accumulation of fuel. And so over time, fire ecologists are actually predicting that we will have fewer large-scale fires. They will be more the ground type fires that grasses carry. And of course, if you have changes to temperature and changes in vegetation, it's also going to change the local hydrology. You know, how much snow accumulates, when it starts to melt, and how much water is going to be in any stream during the summer. So those are all potential changes that fire ecologists are sort of preparing for going forward, given what they've seen in the last 20 years. Some of the mitigation measures to deal with these large-scale fires, one of them is called the Bear Area Emergency Response, or BEAR, and it's an assessment team that comes in after a fire to identify the most critical post-fire stabilization needs. So after a fire is determined that it's been contained and it's safe to go in, this rapid response team will come in and work with the local land managers to decide what needs to happen. So like in our fire, they're going to go in and they'll start stabilizing some of those slopes and determining what the seed needs are and when the best time is to try to reseed for the best potential regrowth. And sometimes it's just a short-term project within a burn, and other times it can be a multi-year project. It depends on, you know, what they decide, how much money is allocated, and what the long-term needs for recovery are determined to be. Another program is called the Healthy Forest Initiative, and this got started in the 2000s under the Bush administration. And one of the things that they came up with is called the Fire and Fire Surrogates Program. And it was a program to use fire and thinning techniques in some combination to determine what combination worked on certain forest types to get sort of back to a healthy forest, you know, a more mosaic forest, less deadened down, and so forth. So they identified 12 areas across the country. Colorado was not one of the selected. We don't have any sites in Colorado, but what they're trying to do is look at how these combinations might work. So what works in Florida is going to be different than what might work in Arizona, than what might work in Oregon. So that's something that they've been studying since, like I say, the early 2000s. Okay, we have a couple more. Come on, you can do it. Oh, okay, the use of prescribed fire and natural fire. So I talked about earlier about using prescribed fire or natural fire within a boundary area. And again, these have to be conducted under really favorable weather and fuel conditions. Having been involved in the prescribed fire program and monitored natural fire, I'm definitely in favor of that. But the problem is, as these WUI communities have expanded and the populations have become more dense, it's become a lot of pushback with smoke. And I get it, I don't like smoke either. And so it's becoming harder and harder to get prescribed fires at the landscape level that needs to happen to restore some of these landscapes to a healthier forest state. So that's one of the things. And then the other thing, as it becomes hotter and drier, it's hard to get these favorable weather conditions and fuel moisture conditions that you need to create a safe fire. In the early 90s, late 80s, there were some prescribed fires that went very, very bad. And that's definitely not what you want to happen. So it's, you know, it's it has its place, but it's becoming harder to use. Natural fires, for the same reason, in terms of smoke, are becoming harder to get to large sizes as well because of smoke in these WUI communities. But they are certainly tools in the toolbox, and managers are trying to continue to use them to the extent that they can. And then the other thing is the Wild Urban Interface Toolkit. So the federal agencies and the state agencies have developed these toolkits and are trying to work with these WUI communities to get the residents to be more proactive. I mean, one of the most basic things is defensible space, which is a term you may have heard. A lot of these folks love having these big conifers, you know, right up next to their house because it's beautiful and it's shady and cool. But the reality is what they're doing is just providing a ladder fuel onto their roof to burn their house down for when a fire moves through. And a lot of times it's at this point, it's when. I mean, it's not if. These landscapes are prone to wildfire. So defensible landscape. But in addition, the toolkits are also working with communities to be more proactive. In Colorado, a lot of these communities have horses and llamas and goats, and you know, so the idea of where can people take their animals if they become evacuated? You know, what's the communication process? How are they done? And so it's to have some proactive communication plans in place and have community buy-in for when there is an evacuation order, so there's less chaos and confusion about what to do, how to get out, where to put their animals. So those are some of the things that you know, we're trying to do, but it is definitely a changing landscape out there, and fire is going to continue to burn. So that's my talk for today. I'm sorry I went a little over my 30 minutes. I used a variety of references from the web and did a lot of reading. So that's just a list of some of the places that I visited. One last thing that I want to just give a shout out. So John Fielder, after I asked him to use our pictures, did tell me about his book, and he has kindly donated one to the silent auction for the fundraiser next month, which I'm really excited about. The book looks really awesome. You can go on his website and you can turn the pages and see what's in there, but it looks like a really interesting book. So for some of you book collectors, this might be one you might want to consider. So thanks for tuning in today, and I think we probably have some time for questions, and I'll turn it over to B to take it from there.